Hello guys, welcome back to my channel Mason African Motives, working on mathematics for grade 11. In this platform we have got some questions that we just want to at least work on analytical geometry. There's some concept and things that we actually need to understand. That is the basic questions that we have got there. So I've got a question guys that I want us to actually focus on from November 2018, basic education paper that is for grade 11 mathematics. So just want us to understand how you're supposed to answer typical questions of this nature. All right, so quickly rushing through the first question that we have got on question number 4, we are given a diagram that we have got in this case. So whenever you're given a diagram, make sure that you understand the information that is on your diagram and also the formulas that you're going to use or to apply. All right, so you've got the vertices and information that is given as the ones that we have. And I want us to rush here where we are given that FG is perpendicular to FC. FG and FC, they are perpendicular, which means if you have to cross check here from F to G, FC, we've got 90 degrees. That is what perpendicular. So this one is actually what your 90 degrees, this right angle here. And N is the point on FG side that the angle of inclination of NC is. Okay, take note, we've got the angle of inclination of this line here, which is NC. Remember, your angle of inclination gives you gradient. Remember that. Yes, it can give you gradient and it can work a lot of things. Like in this case, it can work a lot of things. Anyways, we are also given the angle of inclination of FG. Okay, this is your FG, which is what? Which is beta, this one. And just this angle FNC, which is what? Which is theta. All right. First question, calculate the gradient of FG. That is just 2 marks, guys, for that. Okay, so as we know, from our gradient concept, it's all about the points that you're going to take. This is 4.1, the gradient of FG, which is this is your F, this is your G. We've got the points already. So that is gradient, remember, is the change in Y over the change in X. All right. So we are going to have the gradient of FG, in this case M, which is the change in Y over the change in X. The other thing that you're supposed to know always, Y is the one that is on top, change in Y over change in X, not X on top. Take note, guys. Okay, so that means here from our FG, this is going to be your X1, your Y1 like this. So just name XY there. Okay, your G, this is going to be your X2, your Y2 like that. So you just name your points. So that means Y2 minus Y1, that's 2 minus 2, there's a negative there. Okay, so that's going to be 2 minus 2 like that over X2 minus X1. All right, taking properly each and every point there. All right, so you're going to have 5 in this case, which is your X2 minus your X1, which is what? Which is 2, just like that. So this is what you just have, guys. And for my, that's minus and minus, which is a plus there. So 2 plus 2, which is 4 over 3. So that's your gradient. Yes, you can write it as 1 and 2 over whatever that you're going to write there, but just like that is fine. And also, you know, to simplify your calculator properly, it can actually save you in exam. Okay, anyways, guys, let's move on to 4.2. We were asked to calculate the value of what? The value of y, which is this y here that we have got. Okay, what is happening, guys? How can we find the value of y? Actually, there are so many ways that we could have done in this case. Okay, remember, you are given what? You are given the angle of inclination here, so you can actually use the angle of inclination to find what? The gradient. Then you equate to y. Still, you can find the value. Or if you want to avoid that, therefore, you have to know that if two lines are perpendicular, I know that the product of their gradient is what? Is a negative 1. So I can actually use this because already I have got the gradient of what? Of FG. Okay, let me write down what I'm saying so you clearly understand me. I'm saying if you know that truly FG is perpendicular to FC as stated here, these two are perpendicular. It actually means the gradient of line FG times the gradient of what? Of line FC should give us a negative 1 if the lines are perpendicular. So it can help us now to find the value of y because we can have gradient of fc in terms of y, since already the gradient of fg is there, because already the gradient of fg we determined it here on the first part, and we obtained what? 4/3. So I'm saying 4/3 like this. You want to avoid another calculation times the gradient of what? Of fc. So you can actually find that gradient of fc, or you can just formulate the equation A times the gradient of fc. I must obtain -1, so divide by 4/3 definitely, so that I can obtain what? This. So you divide by 4/3, make sure this is in a bracket so that you obtain the exact answer there. So you just put in a bracket. So this is the gradient of what? Of fc, which is going to give us -1 over this, which is -3/4. But this is not our answer. This is where our answer is going to be taken from. So like I said, maybe you wanted to avoid the concept of the angle of inclination. If you are to use this angle, therefore it's just tan the angle that you have, it gives you the gradient. Because remember guys, that tan theta is equal to what? To gradient. So tan the angle gives us what? The gradient, just like that. So we are going to obtain this value minus, you just round off to give you something that is exact. Once this gradient is there, therefore you are saying I have got the gradient of fc, and I can find this gradient of fc in another way using the formula that I used before of y2 minus y1 over x2 minus x1. So using this formula, I must obtain a gradient of fc which I am supposed to equate to this gradient, to say these two, if they are equal, I'm going to solve the equation. So that means we have to find this gradient of fc, which is equal to y2 minus y1. This time this is going to be your x2 y2, so it's y2 minus y1, which is y minus minus 2. So that's y minus minus 2, which is going to give us a plus, guys, as you can see. Okay, anyways, let me just write, and it's x2 minus x1, which is 6 minus what? 2. So this is going to be your gradient expression, an expression that represents gradient in terms of what? In terms of y for the line fc, which is equal to y plus 2 over 4. So that's 6 minus 2, which is 4. So these two, they are equal. This is the gradient of what? Of mc. This is the gradient of fc, which is minus 3 over 4. So these two, they are equal either way. So if y plus 2 over 4 is equal to this gradient minus 3 over 4, taking it from the gradient of what? Of fc being equal to the gradient of fc from another concept, was it's the same line. So how can a same line you have two gradients which are not the same? Otherwise, this is impossible. So it's for you now to just solve the equation there. So I don't know how you're going to solve it. You can just even multiply by 4 just to remove this, so that you can be left with y plus 2, which is equivalent to what? -3. So y being equal to -2, because it was a plus this side. So the moment you transpose, it's now a -2. So it's -3 minus 2, which is -5. So this is the value of y that you're having. So it simply means that this point here, it's 6 minus 5. This point here is 6 minus 5, because that is 6y, 6 minus 5, just like that. Okay, so that is the value of y. And let's move on to 4.3, which is to calculate now the size of what? The size of theta. Okay, theta is this one, this angle here. That is our theta, as you can see here at n, this one. So how can we find this theta? Okay, there's something that I want you to understand, guys, as you can cross check here from this triangle n to this point to this point. Let's just say this is a, I'm just putting points a and b so that you can understand me. Let's just say this is n, a and b. From this, it's a triangle that we can see. It's a complete triangle. n, a, b is a triangle. Okay, and if you are to see that a, b extended this line, it produces this angle, which is an exterior angle. Actually, this one is an exterior angle. Okay, and we know that this exterior angle is equal to the sum of these two angles. Okay, exterior angle, if you are given a triangle, guys, okay, this is the concept. If I am given a triangle like this, okay, this is my exterior angle. It is equal to the sum of these two opposite angles. If I add these angles, they must give me this exterior angle. So if that is the case, that theta and beta combined together, it's actually like not, it's not the only way that you've got here, because like, okay, let me explain it. What I'm trying to say is that this theta and beta combined together, they must give us what? 104,04. That is 104,04 degrees. So which part am I actually talking of? That is the exterior angle of a triangle. In this case is equal to the sum of opposite interior angles. All right, so this is the reason actually that I've used this to say an exterior angle of a triangle, that you have got a sum of the two opposite interior angles, and these are the two opposite interior angles. But here theta is the one that we want to calculate. This one, we want to calculate theta, this one. We are given this, we do not have this, but we want to calculate. We are not given. Why are we going to have this beta from? Where are we going to have this beta from? Okay, beta is an angle of inclination of this angle of this line FG. This beta here is an angle of what? Of inclination of the line FG, where we know that if it is an angle of inclination, and I told you that whenever you're given an angle of inclination, it means that tan gradient, which is tan theta, is equivalent to the gradient that you'll be having. And in this case, you want to find the theta, which is beta. So we are going to write it as beta, because this beta is the angle of inclination. So it's tan beta in this case that we actually have, which is equal to m. So that means your beta is going to be arctan, the gradient now, of m. Which m are we talking about? Which gradient are we talking about? We are referring to the gradient of fg. It's an angle of inclination of line fg. So it is going to be the gradient of fg, the one that you calculated on the first part here. Remember, you calculated this gradient before. Okay, so you're going to take that gradient, which is your fc in this case, and that was a negative 3/4 actually that you had. It's fc, this one, or it's the other way, which is this, not fc but fg. I'm referring to fg, this one already. Fg is the first part that we did, and it was 4/3. Okay, if you still remember, guys, that was 4/3. Going of fg, that was 4/3. All right, so it's going to be beta in this case, which is arctan 4/3. So that's it, arctan 4/3, which is going to give us 53.13, something like that, degrees. So this is your beta there. So I have got my angle beta, which is the one that was just causing me not to have the exact value of theta, because the major focus is to calculate theta. So now, since I have got this beta, my theta is going to be 104,04 degrees minus what? Minus beta. That's 104,04 degrees minus, but which is the actual beta? Because here is this angle here that we have got. So is it the actual beta, or we're supposed to have this one? Is actually the beta that we talk about in this case. So we are going to take this as 53.1 as it is. Okay, so this is 53.13 degrees. Okay, so the moment I subtract these two angles, I have got the angle theta, the one that I am asked to calculate, and this is going to give us 50.91. That's 50.91 degrees. So that is your theta in this case, which is this angle here. Or you could have just calculated this angle inside this one. Subtract this 104,04 from what? From 180. You determine this angle. Then you add this angle, and theta and beta must give you 180 degrees. So you can formulate an equation. You must obtain the same answer there. All right. Then calculate the length of NC. what is the length of NC, that is this one from this point N to this point, sorry, to this point C here. That's your NC. Do we have any relationship, guys, about this NC? Any relationship? Actually, we do not have the point N. As you can see, we do not have the point N. So we are stuck. Okay, anyways, this is what you're going to do. Back to your normal triangles. Okay, you know that if this is a right angle triangle actually that you've got here, this is a right angle. So I'm just going to take that to shift this right angle triangle. Maybe it will make sense here, this one, to just shift that and put it aside like this. This is what we have got there from that point, because this is where you want to calculate the length, and you are just stuck to say there's no concept that I can use to calculate this, and like it's not a midpoint, I'm not told about that, so I'm stuck. So you have to use what you're given in this case, which is your N, your F, and your C. In this case, I want you to see what is going to happen here. This is 90 degrees actually, and we calculated this angle here, N, and we said this angle N here, the one that we just calculated now is this value, which is 50.1. Actually here, so this value is what is 50.91. So it's the one that I'm going to use there, which is 50.91, like this. All right, so my question is, I want to calculate this length N to C, this length. So it must be that I have any of this length, but I do not have this length of Fn to N, because N is totally unknown. So I'm going to play around with these sides which are known, these two, F and C. So playing around these two sides, F and C, from our diagram here, we are going to see that we can calculate the length of FC. Why? Because the sides there, they have everything is actually what? Everything is actually complete. So I can actually calculate the length of this line FC. And if I have this length of FC, I'm going to use it here now to calculate what? This length of NC. Alright, so let us use now our distance formula. Remember guys, with distance formula, from your formula sheet, FC is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's what you're going to have in this case. Alright, that's the square root of x2 minus x1, which is referring to the line FC. So in this case, this is what we have got already. We mentioned our points before. F and C, we say this is your x2, your x1, so it's 6 minus 2 squared, that's 6 minus 2 squared plus y2 minus y1. In this case, y2 is minus 5. Remember, we calculate this value of y inside is minus 5, so it's minus 5 minus 2, which is going to be something like a plus, because it's minus minus, which is plus 2 squared. So that's what you're going to have. And from your calculator, you can actually determine the length of this, which is going to give us something here, that is 9 plus 4 squared, which is 16, which is something like 25. From your calculator, guys, you can actually use this, which is this is the length of what? Of FC. So if this is the length of FC, then it can help us actually here to find this side. Okay, so let's use that triangle that I wrote for this one, because this is your FC here and it's 5 units, and you want to calculate this, so you can play around now. Your trigonometrical ratios are SOHCAHTOA. Alright, you can actually play a major role now to find this side, because according to this angle that I'm proposing, this is the angle that I am having. I'm only having actually, because this angle here at C, we do not know this angle, so I'm going to use this angle here, theta, which is at N. So according to this angle, this is actually your opposite here, and this side here, according to this angle, your 90 degrees, which is going to be your hypotenuse, the longest side. So we've got opposite and hypotenuse, and that's a ratio of what? Sine opposite over hypotenuse. So since we know that sine theta is equivalent opposite of hypotenuse, that's sine theta, which is this angle, 50,91 is equal to the opposite according to the angle that you are given. Which one is your opposite? This one, which is your 5, over the hypotenuse, which is the NC now, the one that you want to calculate. So you can play around. It's now you and your normal equations, guys. How you play around your normal equations. You can cross multiply, do this and that. Okay, so there are so many ways that you can actually do. So cross multiplying this is going to give us something like NC times this, which is NC sine 50,91, which is equal to 1 times 5, which is 5. So I can divide by sine 50,91 degrees, divide by sine 50,91 degrees. Thus this can cancel and I'll have my NC. So from my calculator, 5 divided by sine 50,91 is going to give us something like 6,4400, something like that. So which is 6,4420, like that. So that is what we have got here for NC. So NC is going to give us 6,44 units. So as you can see, guys, this was a typical question that we had, and it's actually 12 marks for that. And there's a lot of marks that you're going to have in exam just for you to leave this particular question, just say, no, I'm not going to answer this type of a question. No, these are actually a lot of questions, and we have to revise as much as we can on these particular questions before you write any exam that you have. You must be very, very aware of this. So that's what we have got, guys, from this particular section, from Meson African motifs. Till we meet again.